So welcome everyone. My name is Lindsay Elton. I am one of the co-VPs of our Chicago Passive House chapter. You're joined today by a number of folks on the board and in our local Passive House community. We're also joined by a phenomenal colleague who has been working on some groundbreaking projects and has really been involved in moving the sustainability movement forward. So we're absolutely thrilled to have her. Today's event is an exercise in commercial Phius certification, talking about the Techny Prairie Activity Center, which recently got certified as Phius Plus 2018 plus Phius Source Zero certified. It also got an honorable mention in the 2021 Phius Design Competition. So we were extremely thrilled for Lois and the team. And a little bit about Lois. She leads Wight Company's sustainable design initiatives and advances the firm's commitment to offering clients the most effective sustainable solutions. Her work focuses on creating leading-edge sustainable facilities, formulating policies that promote and/or remove barriers to sustainability, and maximizing the environmental potential for projects. The rest of her bio is on the introduction slides, and just a little bit actually before she starts, we were fortunate enough to work with Lois and her team as the Phius verifiers on this project and their first Phius success, the first commercial Phius project in Illinois and the Midwest, I believe. So it's an honor to be here and an honor to have been on our team. And with that, Lois, we'll let you take it away.
Thank you. You're lucky to have Lindsay on this call. I want you to know that I am not a Passive House certified consultant. I'm an architect, I'm a LEED fellow. And for the last, well, I want to say I designed my first net zero energy building in 2003. That was back when people were asking, what the heck is a net zero energy building? And I always maintained that it should be a building that provided enough power on site on an annual basis. There was lots of discussion about whether or not it was just buying green power back then. I designed the Air Station Prairie Nature Center called the Evelyn P. Tyner Center, which was designed initially not to have any full-time operators in it. We designed the building with 6-foot, 12-foot overhangs on the south and the west of the building so that, and we took all exhibits from the building and we put them in the outside so that if the building was closed, people could still come to the visitor center, get access to the bathrooms, and they could have Mother Nature be their space. And the Park District and the community loved the building so much that they proceeded to have it open 100% of the time, which meant that it did not meet its energy budget 100% of the time. So it was not net zero. So since then, we have been engaged in a few net zero energy buildings. As Lindsay mentioned, the Prairie Athletic Rec Center in Plainfield was our first, and Northbrook, which I'm going to share with you tonight, the Techny Prairie Activity Center, was the second passive house building that we've done, and it's very close to being a verified net zero energy building. I think we learned a lot from the first building. There's lots of similarities to it. I'm an architect, very involved in the design of the building, and I'm going to show you a lot of pretty pictures. I'm going to give you a taste of the technical underpinnings of the project, probably less than you want to know, and then I'm going to go into performance. So thankfully, Lindsay is here, and she was the green building rater. So if you have questions to ask her, I am thrilled that she's here with us. So let's see if we can share my screen.
Happy to support.
And I just got back from Florida last week, and this is my second presentation I had to put together in that time. So please bear with me. So here's a picture of the finished Techny Prairie Activity Center. Have any of you actually seen it? I don't know if any of you have been there. Okay, it's in Northbrook, and we're going to start with, let's see how I advance these slides. There we go. Floor plan, it's about 44,000 square feet. And it is a precast building, and as in many rec centers, the rectangle here is a high volume space that's got 10-inch precast panels with the R40 walls, and then the lower space here, which is 1-story space, also serves as the rooftop for the mechanical units being stored out here. And these have 12-inch precast panels. So the building holds a large gymnasium, a large fitness center on the first floor, a childcare center just for itinerant kids coming in to be able to be stowed here while their parents are getting their workout, and the admin space to support the building. It is part of a larger park complex where there's a 9-hole golf course and a skate park and soccer fields. And this was sort of their first large scale rec center they were putting in the suite of their buildings. It does have an upper story, mostly a 8 laps per mile running track with a few good size fitness studios and an exercise mezzanine that's accessed through the fitness area below. So that is the extent of the elements in the building. Now I'm going to show you a bunch of pictures. Here is a picture of the fitness center where, and the sort of irresistible stair that goes up to the fitness center. This is a building that has this is a shot of the track with the fitness center, the studios inboard. The exercise studios are totally interior spaces, but we did things like align the windows so that people in the exercise studios could actually see outside and also see the activity of the things going on to allow for daylight. This is a picture of the lobby. One of the things that as a passive house building that we were very conscious of is the clients wanted a very universal building. So accessibility and inclusion was a big deal. And they wanted to have Star Wars doors. So they wanted doors that were gonna automatically open and close for people coming into the building, which kind of runs counter to keeping a building toasty and, and sealed up tight. And so we actually, in the analysis of the building, we struck the interior partition here as the starting point for the passive house. We took out the vestibule in that part of the of meeting the building. Okay, so moving on, this is a picture of the gymnasium complex. We ran lighting, daylight modeling in the building, and the building was, except for the exercise studios, 100% daylit, because that was really important to us. We have LED lighting everywhere, but who doesn't now, right? Some of our earlier buildings couldn't do that, but now we are. In our first athletic building, we did daylight harvesting, but as we go through this, I'm going to tell you some of the whoops. But the guys didn't circuit it so that the circuits actually ran parallel with the windows, right? So how the lights were circuited was important to how the daylight would function. So in here, 1 or 2 of these banks of lighting can actually dim for that daylight harvesting. But we do have windows on both sides of the gymnasium. I should also tell you that I was a Nazi in terms of orientation of the building. So it is east-west oriented with a fewer percentage of openings on the east and west. There's actually no windows at all on the west of the building and only a few on the east. We were fortunate because we could, the site lent itself to that. And when we were doing different concept designs, we were fortunate that there was a big rail line that ran north-south on the west part of the property. And so we were able to talk the park district into turning its back on the train tracks to limit sound intrusion and also to protect that west side from solar heat gain on the west side. This is a major corridor. All of the corridors and the spaces in the building are sized for people that are passing, where groups are coming in, teams in and out, so that people could actually occupy these common spaces. And we had, you can see, large view windows from this corridor into the gym where, you know, moms could come and sit and watch their kids, charge their devices while they're there, or just hang out. And this is Anya in this picture. She's actually an architect that worked with me, who, as part of doing our second passive house building, Our first team had no passive house consultants. I sent 4 of our team members to training between the first building and the second building. So I had a design architect, a technical architect, our energy modeler, and a mechanical engineer all go through passive house training before our design started, because I wanted them each from their own perspective to understand the underpinnings of going through this passive house consulting capability. This is just another shot of the building as you enter the building. You can see here, this inside, this is the fitness center. This is where people are, you know, on the rats on the wheels. You know, when you're on a treadmill and you're there for a half an hour, you're desperate to have a beautiful view. And so the building only has 16% window to wall ratio overall. And we spent our window to wall ratio, we spent our window credit, I want to say, very carefully to put them where they would do the best they could for the people in the building. This is a shot of the north face of the building. Limited apertures through the windows, but you can see that we actually ran an inscape model so that somebody going along the tracks, we could actually see the views and how they would track the views around as they were running past, just to keep them interested, engaged, and watching the light coming in. And but you can see that it's a limited amount of window to wall ratio. So by the numbers, I told you the building is a 44,000 square feet. The roof was an R60, the walls an R40, and there's the window to wall ratio. In terms of the mechanical systems, we had 3 rooftop units. You can see on the screen their efficiency ratings. And in the low spaces, we had VRF and a dedicated outside air everywhere for the VRF unit, a small DOAS system. In this building, we had much fewer VRF than we had in the first one. And it's actually interesting because the RTUs are providing the major percentage of conditioning in the building, in mechanical conditioning, because they're serving a high volume space and a much larger percentage of the square footage. So we also we ran a model, and we only did the 4 inches of under slab insulation, 4 feet under the slab. So it was an R28 that was a perimeter insulation that ran 4 feet inside. I know that the passive house recommends under slab insulation on the whole thing. That may work for a smaller square footage, but it certainly does kill the budget if you put it under the whole footprint of the building. So we ran a model, because obviously we had to pass the WUFI model. So we made that work. And you can see the U values of the glazing and spandrel glass. And obviously what was really in our favor was not so much the glass characteristics as it was the fact that we had so few glass classes. It's interesting, I asked our energy modeler, John D. Chen, to give me a discussion slide on the mechanical system. And originally, in both PARC and in this one, you know, we found there was a big difference between the way that the mechanical equipment manufacturers set their equipment up and the way we depend on them to run. So normally in a lot of rooftop units, they're mostly electric, right? So there is this question of combustion on site and whether it should be all electric or still continue to have gas. And I'll show you a snapshot of how much gas is being used now, but we've designed these systems so that the gas heat doesn't come on until the building gets to 0 degrees or below. So they're very efficient and they're running in all electric until really those extreme temperatures. And of course, we're in Chicago, so that happens, but we find that that works a lot better when we have the gas set up that way. We had a lot of trouble on the PARC building getting the gas to come on at the right time. Part of the bugaboo has been that in these large gymnasiums, you need to maintain a certain amount of humidity, and you need to maintain that humidity so that you can really maintain your gym floors, right? When they dry out, that's the floors would buckle, and so you really have to maintain the percentage of humidity. And so I know that in the early conversations with Lisa Wight, she was very concerned about condensation and fogging up the windows, which we have not experienced. But sometimes the gas is engaged to help reheat and maintain that humidity. And we've had to really balance the humidification cycles in the building to maintain our energy efficiency. So you can see from this chart that we were able to meet the WFI guidelines. Obviously, we also had to have heat recovery. We had a few issues with heat recovery across our zones because we have the VRF in one area and we have the large volume RTUs in another area, but we were able to figure out how to actually reap that the air off of the system for heat recovery. So here's an aerial of the building, and yes, there's lots of PVs. So this array is almost 100 kW larger than the array at our first facility, because we learned that we had to have wider margins than all of the models showed us we would need. So we have a 300 and almost 13 kilowatt array overhead. The panels are 375 watts apiece, and there are 833 of them. And they were installed at a 10 degrees tilt facing south. Now, our annual predicted production off that array is 368 megawatt hours. At PARC, which is 5,000 square feet less, no, it's 7,000 square feet less, we were meant to harvest 281 megawatt hours off of that one. So just to give you a size difference in one project to the next. So we use the WFI model for compliance with passive house requirements for certification and to prove that we could actually get certified. And then, but we also simultaneously used IES to run our baseline models because we really needed to make sure that we would know how to size the array overhead and how to predict what the energy use is. And so all along in this performance period, we have been measuring the actual building performance against the predicted models, and we can get drilled down to like 15-minute increments on all the different energy uses in the building. We always start with this overall consensus, and you can see the orange on this chart is the gas usage, and the blue is the electrical usage. So you can see overall how little gas the building is actually designed to use. And then under the line is the PVs. So we also, this project was awarded a grant of $1.78 million from the Illinois Clean Energy Community Foundation. And for those of you that are actually here in Illinois, if you're a nonprofit or a 501c3, we are hugely the beneficiaries of a grant program that I don't think any other states can boast of. But you have to be a not-for-profit or a public sector project. And we have actually been successful in getting 3 grants from the foundation, this being the 3rd grant. And the first, originally the grant was $1 million grant. And when we were in the middle of applying for this grant, I went on the foundation's website one day and I saw that the grant was $2 million. I called up the administrator of the grant and I'm like, Gabriella, is the grant $2 million? They had doubled the size of the grant because there weren't enough projects signing up. And so now they've changed the rules a little bit and you can get 80% of your costs in form of a grant. The grant will cover not only the cost of the PVs, it will also cover premium investments in the underlying building. For instance, a building with a precast panel of this size wouldn't necessarily be 12 inches, right? On the lower ones, the lower panels are 10 inches, the higher panels are 12 inches, and that's simply because of the cantilever, the size of the wall panel. We changed the insulation in the panels from polystyrene to polyisocyanurate because of the additional significant additional R value that reaped us. The premium was able to be covered in the grant, and the metering in the building, and the more efficient mechanical system. And the grant requires $50,000 set aside for education in the building. So what you're seeing on the screen now is my long way of getting to the fact that this is a real-time display with this screen of the performance of the building. Obviously, this picture was taken when there wasn't any history to share, but we spent a lot of time with the owner and with Train to map out what would be shown, what would be considered good performance, bad performance, and how it would build over time. On the right side of this panel, we published what the anticipated energy generation would be and energy consumption. And then we hope that over time, that as we get more months down the road, that these follow what was predicted. And then this on the left side of the panel is an actual real size solar panel that is embedded in this, so that people could see the size of a panel, what it looks like, and then we interpreted it over top of it. Then we built a second exhibit, one that showed a truth window through a interior precast panel, and it just shows you all of the insulation that was involved and what the windows were, the triple pane windows. And we also showed them what the R values were, what an R value meant, that we had under slab insulation, that we had 10 inches of insulation on the roof, you know, that we had high efficient systems. So we interpreted what the construction of the building was so that people coming in could understand why this was different and what it meant to be a net zero energy building. So here is last month's data. So the owners are under contract with Aero Building, which is a commissioning company. And they've come a long way because this is the second project they've been on with us, actually the third project, in helping us put together the data. In the first project, we basically, at our Wight, our energy modeler, learned how to download and interpret the actual energy, results that were happening. And as an architect, my experience has been in every other project that we take the project through occupancy, we wave goodbye to the new occupants of the building, we come back every once in a while to say, how's it going? But other than that, we step away. In a net zero energy building, we're there. We're there for the duration because we care that it actually goes from an emerging net zero building to a verified net zero energy building. So here you can see all of the different energy uses. So we have the HVAC is the blue line, and you can see that is the predominant consumption above the zero line on a daily basis in the winter time. And we've segregated the electric HVAC from the gas HVAC. The lighting, which is pretty consistent, the daily plug load, the elevator, and then below the line, what the production is. And you can imagine that this chart changes dramatically throughout the year based on daylight, based on exterior temperature. And we overlay this with the average daily temperature on a day-to-day basis. And so you can look at this, and it really helps to know the temperature, because here it was -5 degrees, and you can see that on this January 26th, you can see how much gas was used. And so when you see that big yellow line, you go, what? And then you look at the temperature and you go, oh, I get it. So it's been really instructive to see this. And when you see the building is meant to produce more energy than it uses every month from March through October. It consumes more energy than it produces November, December, January, and February. And actually, I was on the phone with our guy from Aero Building yesterday, and he said that the person who watches the facility called him this week and said, for the first time, in February, they crossed the line where in a day, the building generated more power than it used underneath. So everybody gets kind of excited about this stuff. So here's the daily PVs, because we're looking at that as well. And we overlay on that the percentage of cloud cover. And so you can see that the days that are cloudy have a real impact on power output. So this is to date the 11 months that since we've been tracking. And right now we need a total net usage. We actually have a total net usage, which means we're in the plus column of almost 20,400 kilowatts to the positive. So in other words, we've generated that much more than we've used underneath. And in February, we're predicted a net consumption, which means look at how much you're producing and how much you're using. And we're about 400 kilowatts to the negative. But last month, we actually had 140% PVs generated as compared to predicted. And so I understand from Aero that the building owners actually sent a crew up and dusted off the PVs a few times, and that has really had a positive impact on energy because everybody wants the building to be net zero. And they've really, we have monthly calls, and they've really looked at the metabolism of the building, how to dial it back. But I can tell you, there's been no sacrifices made for comfort. So one of the things that I like to share is that they're amazed at how comfortable the building is. And, you know, for a long time in the sustainable circles, you'll say, well, if you have to be sustainable, you got to be cold. So just put a damn sweater on and get over it, right? Well, in the PARC building, we actually had a 48-hour period one Christmas where Christmas Eve, the HVAC system was completely turned off. It wasn't turned back on for 48 hours. And the interior temperature, the temperature outside was like 10 degrees. In that 48 hours, the interior temperature only drifted less than 10 degrees. So it's pretty cool to see how passive house buildings really do deliver on comfort. And both facilities are really, they really understand that and talk about that. So we are right now a little less than 2 weeks away from what we hope is going to be a verified net zero energy building. So now I see it's a bunch of stuff in the chat. Let me open it up. And I wasn't reading any of that. So if you want to ask me a question, why don't we just open up the mics?
Sure, I can do that. Lois, thank you so much. It's exciting to hear this perspective from you, being that we were on the verifier side. So we were dealing mostly with the Phius details, but it's really cool to hear, you know, some of this qualitative and more design related information that we weren't, you know, a part of. So Curtis, you had a lot of questions, being that you're from Northbrook. So maybe I'll give it to you.
Oh, okay.
And you can ask away.
Hello, this is so exciting to see. I love it, and I recognize now the area where this building resides, and it's beautiful. So I'm curious, just, you know, of all the sustainability standards for this type of building, how did Passive House get chosen? And what was the reasoning for the PHIUS Source Zero being chosen over some of the other sustainability standards? Even though I love Passive House, just curious. And I guess my second question as well, but I guess, you know, how did it come about that this was a PHIUS Source Zero?
Well, as I've said earlier, we did another rec center that was Passive House. And when we were looking at a Source Zero building, we have a net zero energy building that's verified, that was certified through ILFI's net zero certification. And those buildings are required to be all electric. It did not, I've looked at Passive House side by side with net zero certification. In that case, ILFI was requesting that we reduce the energy efficiency in the building by like 50% over code. That was their goal line. Unlike passive house, which says you can use this much energy for heating and this much energy for cooling. It's a heck of, so in my mind, passive house is the most aggressive energy program there is. And when you have a roof that you have to use as your resource, and that's where you have to put your PVs, you've got to squeeze as much energy out underneath as possible. And passive house gave us that best opportunity. And so it also allowed the use of combustion. It didn't have to be an all electric system. The places where, so the project that's the school, which is Stevenson High School, that does still, that has the other certification. There's no restrooms in that building. There's a few sinks. Water heating's a problem in terms of gas versus electric, right? There's a huge metabolism to that. So I don't think that the marketplace has delivered a technology quite yet. I think we're on the cusp of it, but when you have a building that has a hot water load, it's very tough to meet that. So I believe that I wouldn't be surprised if passive house is going to go towards a no combustion rule, but I think that I hope that the technologies get there so we can deliver to our owners. Because, you know, when you have public owners, they're asking us, is it going to be comfortable? Is it durable? Is it going to work? Am I going to be able to tell my, you know, my constituents why it works? So there's a lot of pressure to actually deliver something that's, you know, that isn't so strange that they can actually live in and get behind and know how to maintain. Does that answer that question?
Absolutely. So I guess you answered the question that this one is not the first. Was the previous one the first rec center ever passive house certified?
I believe it was. I believe it was the first. I believe it was the first one nationally. And I got to tell you that the precast building kind of lends itself to it, because think about it, there's not a lot of seams, all right? Infiltration is a huge contributor. So places we really had to worry about were all the pockets where the steel pocketed into the precast panels, where the roof met the panels was a big issue. We had one issue on the Northbrook, this building, where there was a beam that we didn't catch that created a thermal bridge, and we had to go back and redetail it to prevent a huge thermal bridge into the lobby. But that's the kind of thing you want to do, right? You want to catch that stuff and stop it. So I'm a big fan of passive house in terms of what it delivers. Yeah. And this also is a building type that lends itself to a smaller window to wall ratio. I mean, when you look at those pictures of the building, you don't think, oh, you know, that's like, I have to tell you that the public told me of the PARC building. There was a couple people that said it looks like a prison. And you can imagine as an architect how I felt about that. I'm like, yeah, thanks. Nobody said it once it was up, and I don't think they feel like it anymore. But during design, I was confronted with that. And I was like, that one has a 14% window to wall ratio. So.
Thanks.
Yeah, just one comment on one of Lois's first slides was about where they decided to identify what the boundary was, the passive house boundary. And that's really critical for any passive house project when you're doing the whole building blower door test, is knowing where that air barrier boundary is. And especially so with those types of doors and that type of entry, they're not made to be substantially airtight. So it makes the blower door testing tricky if you have to include that area. So it was beneficial to have it at that entry point. Just wanted to add that note.
Tom had a question.
Oh yeah, sorry.
Me? Yeah, I was just gonna also add that, you know, I think the ICCF limits the options to passive house and living building panel, which is nice too. You know, it's nice to have, because that's how I've done one of these too, and it came via that requirement.
Thank you. I forgot that. Yep.
And one of the big challenges I had the privilege of working on a school remodeling that received the ICCF grant. And one of the big challenges was the scheduling and working out the occupancy. What kind of things do you have to do? And I don't know how I'd approach that for this project. It seems like it could potentially be all over the place. How did you get a good kind of handle on the occupancy schedule and load and all of that?
Lots of conversation with the owners.
Okay. So you didn't
Really,
pull
I
out,
mean, more than once around the track on that one.
yeah, like how many expecting there? So you didn't just pull out like an average from ASHRAE book or something?
No, because the actual occupancy mechanically would make the building array have to be 3 times the size. It has nothing to do with, but the gym, they are designed for really high occupancy because you can run like 4 different teams on those courts, because there's 2 courts, they can be divided into half, which means you can have 10 kids, 40 kids plus all their parents and everything. And all of a sudden it really jacks up the occupancy on that building. And really these buildings are driven by ventilation. There's such and passive house traditionally doesn't really allow for that kind of, they considered it a process load and gave us an actual exception for ventilation, but we had to provide ventilation for ASHRAE, which I don't think is really well contemplated in WFI yet. Was that your experience, Tom?
Yeah, I would say so. I mean, it was definitely, figuring out the ventilation schedule and how, when the equipment was actually going to be run, was a big challenge. And it was definitely the thing that kept exploding the model. Well, what if we didn't use it on Thursday, 2 nights a week? There were all these things. It was a school and they wanted to use it after hours. And unfortunately, we got into a position where we've got the client to just agree to not use their building sometimes, which is not really where you want to be and not the spirit of things. But that's, it got just very tricky. We're going to have to understand how you're going to use it. And it might mean you have to commit to some things that are less than you want to initially for that first year until you get your monitoring data in. So,
Lois, did you consider geothermal ever?
No, because of the price point and because the VRF systems were so efficient and sort of give you the same efficiency of a geothermal, and because the gymnasium and the fitness center also anyway require high volume air. We find the systems are so much more efficient now, the rooftops, that we didn't really consider geothermal. We would have had to have big air handling units anyway.
I recall one interesting thing with the air handling, or the RTU and the duct sock that was used. So if folks aren't familiar with what a duct sock is, it's literally like an inflatable sock that's connected to the RTU, and it's got a series of holes all around the sphere, and it just delivers it throughout a space. But when you look at what PHIUS's verification requirements are, they want you to be able to test a certain spot, and it's not possible with all of those holes and all those locations. So we had a call with the duct sock manufacturer, as well as Tony Lasanti and I think James Ortega from PHIUS, to talk about how we were supposed to handle this from a verification perspective. And as we couldn't follow typical protocol for PHIUS, what would they accept and what would they allow? So they gave us an alternative compliance option for it. So that was an interesting aspect that we found on there with the heating and cooling side of things.
That happened on river trails too, didn't it?
I believe that happened on river trails.
Yeah.
So on the PARC building, the first building, and of course I can't calculate it yet on this building, but the EUI after 12 months of data was 23 before the PVs. With the PVs in the first year, because we didn't quite make net zero, it was 1.75. So we were really close to net zero energy, and we're still actually working through trying to meet that protocol. We're actually adding more PVs on. Part of the reason was anomalies in inverters and all kinds of things happening with the solar guys. The ILFI building had a EUI of 32. So I and after with the PVs, the PV ratio was much higher on a square footage basis, and it had a minus 3.75 BUI with including the PVs. So we were able to handily make that net zero energy goal, but I still think there's a huge, to me, it demonstrates the benefit of passive house on just a raw energy perspective, on an efficiency basis. And we've been talking about decarbonization in our area, and there's conversations going on all over the place about it. And there is a study that was done by NYSERDA that said that if we converted all of our building conditioning to the heating cycle to electric, we'd have to double the size of the grid. We can't afford to do that, which means we have to really drive efficiency, and we have to continue to disaggregate our power sources by putting solar where we can. So I think there's real benefit to it.
Tony, did you have a question?
Hey there, thank you very much for sharing all that. Of course, in our passive house world, the two things that we talk about most are continuous insulation and air tightness. Did you have any challenges in air sealing the precast and meeting the FAIA targets for air tightness?
I don't think so. And there was more care that was taken in sealing around the windows and sealing panel to panel. I know that the contractors, they had to really pay attention more than they might in a conventional scenario, but I don't really think there was any issues.
Did you hit the targets with the first shot, or did you need any remediation or follow-up?
Gotta ask Lindsay.
I remember one interesting part of the conversation at the beginning was had to do with WFI compliance and adjusting the blower door target that we used, and we somewhat petitioned passive house to see if they could give us a more relaxed target and take us, I think we had 0.02 or 0.025 or something like that, and that just seemed really aggressive. So we were able to talk them through that, and we were allowed to get the 0.05 target again, or 0.06 target. And then with the air sealing, we came on site a few times. That the team did a great job. Like, they were really eager and willing to do whatever it took, and to hear and to learn about different techniques, or where more attention was needed. So that was great to see. And then the testing that we did, if we didn't get it automatically on the first time, we got it on the second time. And one of the things that we had to work through was the continuous ventilation and having dampers. And so once we were able to kind of work through some of the programmatic things with Phius, we were fine. Yeah, it's been wonderful with some of the struggles on some of the other projects. Like, they were wonderful to work with, I will say.
Very nice. Do you know if they had a two-stage joint seal on the precast, meaning a double line for the exterior and an interior one?
I don't recall, Tony.
Okay.
Yeah, I don't. I think they did a wall mock-up in which they showed us where all the sealing was done, and they were very conscientious about their sealant. So, but I can't remember if that was done either.
Had any of the builders taken the builder training? Do you know the Phius builder training?
I don't think they did.
Okay, that helps too, because we did have in the River Trails School, the builder did send 2 people to the training, which I thought was a nice gesture and a good one to help things work out, I think.
So Tom, was your building a retrofit, or was it a brand new building?
It was, but they redid the whole exterior, so it was able to do the continuous insulation. So the wall details look pretty much like if you drew them new. I mean, there wasn't any kind of weird conditions you had to deal with. The only big thing was I had an uninsulated slab on grade, which a new standard gives you allowances for, but at the time they didn't.
And how's it going toward net zero energy?
Well, we haven't done the monitoring yet. It's just about to start. I think next month they're starting the official monitoring, but we're crossing our fingers. Oh,
Get ready.
I don't, there's always opportunities for stress on there. First it's the blower door test. Now it's this. What kind of percentage was your capacity over what your projection was? How much of a buffer did you build in? Do you remember?
Boy, I wish I remembered. I think we aimed for 10% at least.
Okay.
I'm not sure if we ended up with that. I don't remember. I know that I mean, I can tell you my engineering team, after suffering through the first project where the PVs were 15% less, you know, I expected the PVs were just going to generate what they said, right? You plug it in, the sun comes up, the sun goes down, but there were issues with roof drains overflowing and swamping cables and inverters going out and inverter companies disappearing, and oh my God. But I think we had a 6% margin on that project. So
Okay. We did a pretty generous margin.
Did you?
But also, you know, ICCF doesn't really want you to do a crazy, you know, why don't you just do what you're designing it for? Well, there's a lot of contingencies in this, you know.
And ComEd doesn't want you to do it either.
Yeah, that's true. Yeah.
ComEd really doesn't want it either. I hope that you have a good team that are going to be looking at the numbers as you go through, because we found in PARC you can't just wait for a month to go by and then say, okay, how'd we do? Maybe the first month, but after that, when you tweak the system, you need to know that it's going to result in the results you want. So there's a big difference between the PARC project and the TPAC project. The TPAC project has an owner who is a building guy who is on the system. And like, he's the one that called the commissioning guys and said, hey, we generated more power today than we used. You know, that's how enthusiastic he is and how he's really worked in tweaking the system in terms of, you know, set points and stuff, and been really proactive, which means that maybe in our very first 12 months of performance, we're going to actually meet the target. But having that person on site that says, yes, I can, and I understand it. And then having we made our commissioning contractors be signed up not only to do the commissioning, but also to do 18 months of performance, so that because that's the period in which you have to have, right, your performance period. So we got them to actually be the ones that would report the metering. We gave them the targets from the energy modeler in all of the different categories, and we said, this is what it has to do, and they report in that format every month so that we can see how the building's doing.
So the time is 5:58. Lois, I know you have to get out soon. So I just want to ask one quick question, since I'm going to take the floor. What do you have planned next? What is on your horizon for net zero or Phius or anything?
Well, we have a project that's in for LEED certification that we're going to put through LEED Zero. And we have a project that we're actually building that is a Phius project. We're not the designers, we're going to be the builders for that. And we have a project under design now that is not Phius, is probably going to go through ILFI. So we continue to try and analyze each project based on the nuances. The one that's not going through, that is our latest one under design, is an animal care facility, and there's just really wacko ventilation requirements, and Passive House doesn't want to have anything to do with that. So we're looking at that, and we are. I see, Ted, your comment on embodied carbon. We're actually looking at the embodied carbon because we do a lot of renovations, and so we're looking at the embodied carbon of renovating versus building new. I've got an intern starting next month who is going to do nothing but help us research embodied carbon and get our team going. We're signatories to SC 2050, which is that we would have embodied carbon targets to 0 by 2050. So yeah.
Lots of great stuff. Well, thank you so much on behalf of all of us. We greatly appreciate your time and your sharing your story with us. And in respect of time, thank you. We'll let you go.
Thank you.
And we'll hopefully see you soon.
Okay, thanks, everybody. Have a good
All right.
evening.
All right,
Take
thank
care.
you.